Hello there. Today we'll be doing valid anagrams. This is a arrays and hashing problem. So let's get to it. So in this problem, we are looking at two words and we're finding out if these two words uses the same number of characters. And so this means that there are multiple characters that can be the same. So we can use a counter to do this problem. And a one-liner that is O of n time and of O of n space. Well, not O of n space, actually. It's O of 1 space because it is counting 26 characters. Of course, this is somewhat unacceptable because what we want to do is show that we understand hashing and arrays. So let's learn about it a little bit. Let's use the default dictionary, two of them, and we're gonna do each character in each particular string and add that character once every time we see it. A better wording is, instead of #1 and #2, would be #s and #t. Let's see. Oh, shoot. This is T, my bad. And let's run that. Okay, it's still slightly slow. But what we're seeing here is that we're making sure that this particular hash uses all the characters that were necessary, and we add every time we find a character, and we make sure if they're equal or not. This uses the hash map, which helps us because it gives us ability to track down the number of times we've seen a character rather than just if we've seen a character or not using a set. Another thing is we could use the factor of what we're doing here helps us see whether two things are equal in terms of number of characters that are the same. Another thing that we could do is use a sorted, and that way we can sort the strings in terms of and that way all the same characters are aligned in an array. So what are we learning here? Well, we are learning the fact that this is how you can count certain characters in an array. Suppose we were forced to use an array instead. We could use the Unicode. So count s and count t is equal to 0 times 256. This is how you get 256 zeros. So for C in S and count S at word of C plus equals 1. For C in T, count T word of C plus equals 1. And then we can return count S equals count T. This way we use exactly 256 characters in terms of the Unicode, and it looks like we got a pretty great answer here. Much faster in dictionary, much faster than the counter, probably much faster than the sorted too, and we did this pretty quickly. This is our fastest one yet, and that's another way to creatively use an array to solve this problem. And this works for all the Unicodes up to 256 bits. If we had more, if we had a 64-bit problem, we would need 4 billion places to count, and array would not be like memory efficient in that point. So I think the dictionary would make a little bit more sense because you're only using space for characters you use. Otherwise, we don't create it at all. That's the beauty of the dictionary. I think we have gone over just about everything that we could go over for this problem. I think the concept here is to learn to more effectively use arrays and hash maps to count items in a string. Well, if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and have a good one.